Hello everyone, how are you all? I hope you are doing great. If you are a bit tensed in these days, I wouldn't be surprised because I know the exams are nearby. And everyone would be saying now nothing could be done much because already few days are left. If you have done something really well the whole year, then there's a possibility you'll get a good result. If you haven't, then better luck next time. I would say next time. Wish you will do it this time itself. But are there certain things that we can do in these remaining days? And I say yes, you can. These days are really crucial. If you utilize these days really well, and one of the things you can do in these days, which we'll be discussing, then I can guarantee you can improve your result in multiple folds. So what is that we can do in these days? How about now we have an overall view on the exams, the patterns let's observe, and are there certain questions which can be most probable? Are there certain topics which are asked again and again? So that we can be sure this time also a question will be based on that, and we can at least be prepared for such kind of questions. And yes, certainly it can be done. It requires a bit of research, and that's what I have done, and I want to present it to you. So we are discussing about some of the most probable questions, I would say, which are to come in the physics paper of the 12th board examination. This research is based on the facts I've observed so far in the exam. And let me tell you, there's a clear-cut pattern that can be observed, and based on that only I'll be sharing with you. So without wasting any time, let's go for it, what you're waiting for. Okay, so let me start with the first topic, which you can be very sure that yes, certainly you would going to have a question on that. So let me begin with that topic, and that's the EMI, the electromagnetic induction I'm talking about. You can be very sure that there is a question from it. And if I present to you the research, I've seen that in just last year paper, you had the question based on Lenz's law. You had the question from mutual and the self-inductance. Then just the year before that, you had the question from motional EMF. Lenz's law was again there. And the year prior to that, 2015, you had a question on mutual inductance. Right. So there's a clear-cut pattern. You see mutual inductance being asked alternatively, and so as the motional EMF. So since last year motional EMF was not there, you can be very sure that this time there would be a question on motional EMF, right? And so what kind of question which you could expect? So let's have that most probable question that you could expect from motional EMF I'm talking. Have a look at this question. There's a situation given to you. There are two wires which are sliding on frictionless rails, right? These wires, these rods, I could say them, they have their own resistance, 2 ohm each. Also we have another resistance which is connecting the two rails, which is 19 ohm itself. The distance is given between the rails, 4 centimeter. The magnetic field going into the plane is also given, which is 1 Tesla. Right? How are you going to solve such question? Well, also given to you that now suppose these wires are given velocity, the PQ and RS wire. Obviously you know then only an EMF would be generated so that you could see a current. Until unless there is no motion, you won't be having any current. So if you give it motion, let's say 5 centimeter per second velocity towards right, then what is going to happen? And then also there's a B part, what would happen if they start moving away rather than going in the same direction? So what do you think? How are you going to solve this question? Of course each of the rod would act as a battery. If you'll have both moving in the same direction, each battery's EMF would be given by BVL. They're going in the same direction, the current will add up from both of them. If you have them going in the opposite direction, it will be opposite, and obviously then they will cancel each other out and you will not see any current. So in B part you would clearly say that it's a 0. And in the first part you can easily calculate. The current would be just addition of what is coming from the two batteries. So again, if I had to tell you that what are the important concepts you could go for in this chapter. So again, most probably motional EMF this time. But don't forget to also look out for Lenz's law and mutual and self-inductance. the solenoid problems and so on, which are very important. Okay, moving further ahead, the next important topic, the photoelectric effect, right? Every time almost there's a question on photoelectric effect, and that too quite predictable. Like just last year, there was a question regarding stopping potential and intensity, like how does stopping potential varies? Can it change if we increase the intensity of light? What happens to the saturation current and so on? These questions were there. So you really need to be very up with your concept of photoelectric effect. Remember that you not only do numericals in photoelectric effect, it's very important to do the concepts, like how and what is the reason that even if you increase the intensity of light, the stopping potential doesn't change. What is the reason behind it? So go into the concepts as well, to the very core. That's very important. So let's look at the fact, the trend. Let us observe what was happening. Then in 2016 you had question on Einstein equation, which is, you can say, the backbone of the photoelectric effect. De Broglie wavelength also you need to be look after. Just year before that also you had a question like that, de Broglie wavelength, stopping potential and intensity. Alright, so now what shall we predict this time? So since last year was not a question on Einstein equation, so this time most probably there will be a question on Einstein equation. So let's have a look at what kind of question it would be. So the question would be like this. First of all, theoretical, as I said, you need to be up on your concept in this. So that the question is, write Einstein's photoelectric equation, the kinetic energy equation, maximum kinetic energy the electron has, right? Then the important features you need to mention. Then there is a question which is based on the concept you have just explained. So the next part what you see is a numerical. You've been given the maximum kinetic energy of photoelectron gets doubled when the wavelength of the light incident on the surface changes from lambda 1 to lambda 2. So obviously, I guess if you know the Einstein's equation, you can write the kinetic energy equation, right? And you know how it depends on the wavelength, right? The incident wavelength. If you double that wavelength, they have given that the kinetic energy also will double. So obviously the work function will not going to change. So based on those two equations, you can easily compare. So that's how it is to be done. Alright, so what are the important concepts if I have to discuss from this? Einstein's equation again, because this time we are predicting it could be from Einstein's equation. Now you had also seen the graphs in photoelectric effect, very important. Do the graphs, okay? And also then de Broglie wavelength, anytime this can be a question. Alright, so that's what we have from photoelectric effect. Let's move to the next important concept. Optics, one of the favorite topic of 12th board examination. And why not? Because you have multiple concepts in this. And what you will observe from the trend is that the optics question are very much predictable. The most predictable questions would be from optics. Like one can give it in return that there will be a question on Young's double slit experiment. That's quite obvious. So just like that, you can observe the trend. Let me again put the trend in front of you based on the research. So here's the trend. You had the question from Prism, Young's double slit experiment, that is what is meant by YDSE there. Then refraction at curved surface, that was also asked last time. Huygens principles, important again, combination of lenses. Instead of one lens you use two. In that also two types. If the lenses are far apart, they are close together, what would happen? The equivalent lens. 2016, you can see again YDSE, Young's double slit experiment. Then the Mahler's law, that's very important again. They talk about polarization and so on. Huygens principle again, Prism, one more time. Just the year before that, look at there how many concepts they have asked. Mirror formula, Mahler's law, telescope, problem based on that. Young's double slit experiment again, that is not absent in any of the year, you can observe that. Huygens principle again, not absent. Reflection at curved surface and so on. So do you observe that how important it is to do the optics portion? Because the questions are very much predictable, almost as if the same thing are repeated again and again. So read the Young's double slit experiment really well. try out all the numericals, then also try out the angular part in that, right? You have two ways to look at it. So angular part is also there in the Young's diversity experiment. Okay. Do the derivation of Huygens principle. Very important, Huygens principle derivations. That how you can prove the laws of reflection using Huygens principle. So look at the wave front and so on, simple geometry you can use to prove it. That will be really important. Do the Mahler's law for polarizers. Very important. So this time, again, it won't be a surprise if I tell to you that this time also there will be a question on Young's double slit experiment. The only question remains, what kind of? So let's have a look at it, what kind of question we could have. So here is the one. It's given to you. In Young's double slit experiment, derive the condition for constructive interference and destructive interference at a point on the screen. So they're not only asking you the numerical, so the person who thinks let me only do the numericals, I'll be able to solve the Young's double slit experiment question, would go really wrong in this case. Because what you see is first they are asking you the conditions. So you must be aware of them. Then after that they go in the B part to talk about the actual numerical based on it. So there's a beam of light which consists of multiple wavelengths, basically two they've given here, 800 nanometer, 600 nanometer, and through that you're observing the interference pattern on the screen. The screen distance is given, the distance between the slits is given, right? Now each of the color, I could say them color, although I should not, but these are two wavelengths you can say, and these two wavelengths will form their own pattern on the screen. So each of that will going to have its pattern. Now they are asking of these two wavelengths, what is, if the two slits are separated by this distance, calculate the least distance from the central bright maximum where the bright fringes of the two wavelengths coincide. So basically you have the bright spot coming. Basically they are talking about the first one. First bright spot of one wavelength, the first bright spot of the other wavelength also. And they are asking the distance between the two. You can easily do find out for the first, find out for the other, subtract the two, you get the distance between the two. Very easy, right? So that's it. You can have full marks in this. So do prepare Young's double slit experiment for this exam. If I had to put again in front of you what are the important concepts. So here they are. Snell's law, very important, simple as well, don't forget it. Total internal reflection also, don't forget. Mahler's law, you cannot even think of leaving it. Young's double slit experiment, don't forget to do it. We are predicting the question on that. And also, I could have put a question, but now I leave it up to you that you may also expect a question from optical instrument, right? There might be a question on telescope and other kind of thing. So do that as well. All right, moving ahead, the next topic, electronics and communication. Again, one of the most favorite topic you can say for the 12th board exam. Also, what is special about this topic is that if you are also preparing for entrance examination, you don't see it in the JEE Advanced. It's not in the syllabus of JEE Advanced. It is there in the syllabus of JEE Mains. So you also see questions appearing in JEE Mains from this topic, right? And 12th board anyway. And it covers a huge portion, right? That's why it is there all the time, a question from this topic. So you can easily expect this time also. So let's first have a look at the trend. So there was last year question on diode circuit. A diode circuit was given and things were asked. Amplitude modulation as usual and logic gates. Year before that, again logic gates and diode. Just year before that, amplitude modulation and transistor. Question based on it. So what can we expect this time? Well, I can tell you that since it is almost having two parts, electronics and communication, so when it comes to electronics part, you can easily expect a question from the logic gates. And that is quite simple as well, quite scoring as well. Right? So you can expect a question from logic gates. When it comes to the communication part, what is there to ask? One part is the amplitude modulation. So never ever leave that. That's the only topic you have to do in that. So do the derivations of amplitude modulation, do the block diagrams. One year I saw there was a question, they have given the block diagram of all the channels, receiver and all those things in between, how does the noise get added up and so on. So do that block diagram as well. and few of the blocks they have left blank, and they said, you fill it up, what should be there. Okay, so do amplitude modulation really well. Okay, apart from that, what could I expect? You can expect transistor questions, transistor characteristic based on that, transistor configuration. Now, let's predict the question, try to predict a question which could be from the logic gates. Obviously, it won't be too easy question. They would try that you think a bit before answering. So like that one question I'm putting in front of you. Have a look at the question. These are the figures, and A and B are the input to the logic gates. And what you see Y is the output, right? So A and B are given input, and you have been given the Y output. The graph is given, how they are varying. Obviously, the input output could only be binary, so it's either high or either it's low, right? So that's how you see the pattern. What do you observe? Do you see a certain pattern? Which gate can does this? If you give high and high at the same time, it gives you low. Then if you put low and low, you get high. One low, one high, again high, and so on. The pattern is continuing. What do you think? Easy, right? Can you expect which gate will going to answer or will going to satisfy this condition? How about NAND gate? Because when you have high and high, 1 into 1, that's 1, and then you take its NOT. That's what NAND is. First do the AND and then take the NOT, and then you get the 0. Then also when both were 0, low and low, NAND will give you 0 and you take its NOT, you get 1. So everywhere you can see there is the NAND gate which is satisfying this condition. So there it is, you got the answer. Again, I'll make you aware of the important concepts in this: logic gates, amplitude modulation, don't even think about leaving it. Transistor diode characteristics, especially the graph, do observe them. And transistor configuration. They might ask you to draw the circuit diagram when it is in the common emitter configuration, common base, and so on. Alright, so that's it from electronics communication. Let's move further ahead. Talk about the next topic. There you go, electrostatics. Interesting topic, isn't it? What do you expect? Electrostatic. So here is the trend, I can tell in front of you. Gauss law, very important. Do you see in every year it is written Gauss law? So Gauss law question are pretty much sure you could have from it. Capacitor circuit, look at that. Again, every year you are observing that capacitor circuit question. Then dipole. Interestingly, dipole is also coming every year. How predictable this is. How can we be blind to such a trend in the exam? Isn't it? That's why I was saying that these days are really crucial, right? You can easily get to know the problems that are coming. So this time also you can expect a question on capacitor circuit. You can expect it from the Gauss law, dipole again. And when it comes to dipole, let me remind you, I saw a trend where they also ask you the derivation of the dipole, like the field variation due to a dipole at a certain distance, the potential variance, and so on. So not only that you are required to remember the formula, you need to know the derivations as well. That's really important. Okay, let me move ahead and give you the predictable question. So as I said, Gauss law and capacitor circuit every time asked. So I've made two such questions. Let me put in front of you. First is based on the Gauss law. You've been given an electric field which is uniform, which is given in the vector form. It's along the x-axis, and they are asking you the flux of this field through a square which is 10 centimeter side and whose plane is parallel to the YZ plane, right? So obviously you would have to imagine in 3D how that square is, but it's quite easy to do that, isn't it? So you can easily see here the field is also constant, so it's interesting, and the plane will be parallel to the YZ, so you have to imagine this coordinate axis. Your plane will be like this, right, and field will be hitting like this. So you can easily calculate the flux. What is it? Field times area of the square. Yeah, really easy, isn't it? Alright, so that's what you can expect from the Gauss law. Let's move to the capacitor circuit question. So here you have the question from capacitor circuit. Given to you that there's a capacitor of unknown capacitors, we don't know that, and it was connected to a battery which is also V volt. Interesting, nothing is given. We've been given that the charge stored in it is 360 microcoulomb. Now when the potential across the capacitor is reduced by 120 volt, remember here people might make a mistake. They are saying we have reduced it by 120. They're not saying we have made it 120. So whatever it was V, now it will be V minus 120. Don't forget that. Okay. And when we do that, you see that the charge reduces to 120 microcoulomb. Now here 120 microcoulomb is not the reduction, it's the final charge. They are saying that finally the charge stored in it becomes this. Okay. So this is the value of the charge finally when you reduce the potential by 120. So easily you can have two equations. You can apply Q equals CV, that is 360 microcoulomb equals CV, and then put the next time 120 microcoulombs equal C times, and you have the potential reduced to V minus 120. And easily you can solve the two equations to get the value of V as well, to get the value of C as well. Right? So that's what the first part is. The potential V and the unknown capacitance C you need to find out. Right? What will be the charge stored in the capacitor if the voltage applied had increased by 120? Right? So now you know the value of capacitance, isn't it? And they are saying that the value of voltage is increased by 120. So whatever value of V you get in the first part, add 120 to it, right? And based on that new V value, you already have the C. You'll get the new charge by simply multiplying C times V. That's it. Easy, right? Okay. Let's move to the next topic. Before that, let me also remind you the important concepts in front of you. So the first important concept is electric flux, obviously Gauss law. Cannot imagine to leave that. Dipole and capacitors. These are really important, and short questions are there from that. You can observe it if you don't believe me. This is the trend, isn't it? So do the dipole derivations, again I remind you. Alright, move further ahead to the next important topic, which is the current electricity. Okay, first have a look at the trends. Wheatstone bridge. Interesting, Wheatstone bridge is coming up. I also see Wheatstone bridge in 2015. Do you see that? So is it like that there's an alternate pattern in this, that one time they asked, one time they didn't, right? In 2016 they asked circuit based question, which is the Kirchhoff's law you would have to apply, right? Heat in the resistor, pretty easy, I square RT, you just do that and you get the heat. Galvanometer, so these measuring instruments, I can put the word for all of them, whether it's the amp meter, whether it's the voltmeter, we call them measuring instruments. So important concepts, if I had to put you right in front here itself, that Kirchhoff's law is very important, Wheatstone bridge very important, measuring instruments again very important. So I see a alternate pattern, the 2015 Wheatstone bridge, 16 it was not, 17 last year it was, so this time again probably it won't be. So what could be? It could be Kirchhoff's law question, obviously circuit based, that is what I mean. So this time also expect a circuit based question, have a look at it, what kind of question you can expect. There you go. You have been given a circuit, you have been said that calculate the value of resistance R in the circuit shown in the figure, so that the current in the circuit is 0.2 ampere. What would be the potential difference between B and E? So there are two parts of this question, right? So what do you think? How are you going to solve this question? Well, this circuit looks quite complex, but you can reduce it to quite simple circuit. What you see on the other side, those 5 and 10 ohm resistor at the very end you start from are clearly in series. Then their combination, which is 15, will be in parallel with 10. Then whatever the equivalent of those two will be again in parallel with 30. So after having that equivalent of that rightward part, that is the part BCED, you can just reduce it to a single resistor. And so now in overall circuit you will see two batteries, 8 volts, 3 volts, one resistor R which is unknown, 15 ohm would be there, and the one which you have found the equivalent. So you reduce the circuit just to 3 resistor and 2 battery. And then it's pretty easy, because you can easily apply now the Kirchhoff's law. And once you apply that, you easily can get the answer for the current, right? And after that you can get the answer for the potential as well, because now that current is going through there, you can divide it and easily give the potential difference between the point B and E. And that will be the answer for your question, isn't it? So pretty easy. So again, important questions, important concepts I should say. Kirchhoff's law, Wheatstone bridge, measuring instruments. That is, do remember the concepts of measuring instrument. That is when you have to talk about amp meter. What should be the shunt resistor? Should it be in series, in parallel, for that is I'm talking about the galvanometer conversion. You want to convert into ammeter, you want to convert into voltmeter, what kind of shunt resistance should be, what should be its value, and so on. Right? Keep that in mind. There are ways to learn that. So do that. All right. So we are also done with current electricity. Time to move ahead. And there it is, the magnetism. I hope you must be waiting for this, isn't it? Okay, so let's observe the trend first. 2017, just last year, you had the field due to a current carrying loop. Very important, right? You should also remember the expression. It should be there on your tips. The formula looks quite complex, but there are ways you can easily understand it. Okay, so that was the question. 2016, there was question on Ampere's law. 2015, also Ampere's law, right? So Ampere's law again becomes really important. So do the Ampere's law really well. It's an important thing. Then also you should be knowing the field due to whether it's a circular loop, whether it's a wire, and how the field lines are, what is their magnitude, and so on. The Biot-Savart law, very important. Then important concepts if I put in front of you. Force on moving charge in magnetism. They might give you a question where you have a charge and it moves in the magnetic field. What do you expect? It is a moving charge magnetic field. You got it right. It experiences the force. It will go in a circular motion, isn't it? So that concept is really important. Now obviously they won't be giving that easy. Then you have just been given a charge is moving in the magnetic field and you just find the force, radius of it is mv over qb. You already be knowing that. The question becomes interesting if apart from magnetic field, there's also an electric field existing there. So now it becomes interesting because there will be two forces now. One, the magnetic force, one, the electrostatic force. Now, although no longer the charge is static, still the force due to electric field, I should say. Isn't it? So then you imagine force from here as well, force from there as well, and the net force and so on. That will be interesting question. So have a look at it. Question which I predict for the paper this time. So what you see in that is there might be a question where there would be charge again as I said moving in the magnetic field and then there will be electric field as well. What is also important in this is the loop. You have a loop which plays in the magnetic field and you know that if you switch on the magnetic field there will be force acting on it if there is a current in the loop, right? Because obviously any current carrying conductor, there is a force that acts on it, isn't it? And if you have a proper loop, one direction force is going up, one direction force is going down, although the net force is zero, the net torque is at zero, and so the loop starts rotating, isn't it? So that is also there. So question based on the magnetic moment of the loop, you know it's the current times the area vector, isn't it? So that is there. And apart from that, what do you expect is the question I said where electric field, at the same time the magnetic field also existing. Right? So these are the few questions which I predicted. So these things can really help you in making your score go really well in these days. So do study these topics, do the derivations as well, whatever I have mentioned, starting from the Huygens principles derivation of laws of reflection to the dipoles derivation and so on. And you already remember what are the topics I have already told you. So what I can do now is wish you all the best, try it out, and I hope you really well in the future. Thank you.